All right. Welcome back to my YouTube channel. Today, we're going to continue with integration by partial fraction. In our last example, we took um, integration by partial fraction where repeated roots or repeated factor is in effect or is involved. Today, we're going to look at solve a problem where the degree of the expression at the numerator is higher, or let's say has a higher degree, okay, than the one at the uh, denominator. So what am I saying? If you have been observant enough, you would notice that if you will notice that the previous examples we have solved, that the degree of the power or the highest power of x, value of x, or any variable that we are integrating with respect to, if the degree is higher, that the degree of the ones who have solved previously is lower than the degree the denominator. Okay, so today use we're going to solve a problem where the degree of the numerator is higher than the degree of the denominator. So you will see how we can use long division method to reduce the degree at the numerator, and then we resolve the later um, fraction uh, with partial fraction, and then we integrate what we have afterwards. Okay, so without wasting much of our time, let's go into the video. So today we are going to take example. This should be example 3, if I'm not mistaken. This should be example 3. Okay, so in example 3, we're going to evaluate the integral of 2x to the power 3 minus 2x to the power 2 minus 2x minus 7 all over x squared minus x minus 2 dx. Solution. Okay, so what we're going to do is we're going to pull out this fraction. We're going to pull out this fraction, and then because the highest power of x, like I said before, at the numerator of the expression at the numerator, of the polynomial expression at the numerator, is higher than the degree of the one at the denominator. So we're going to use long division so that the later fraction, we have a degree that is less than the one at the denominator. So we can now resolve into partial fraction and then integrate. All right, so now we have this as the divisor. The divisor, x squared minus x minus 2. And this is the dividend, x squared, 2x cubed, okay, minus 2x squared minus 2x minus 7. Okay, so x squared divide 2x cubed, we would have 2x. Okay, then this multiply that, we have this back. This multiply this, we'll have plus. This multiply this, sorry, we'll have minus 2x squared. Okay. Then this multiply this, we'll have minus 4x. Okay. Then we're going to subtract. We bring down minus 7 minus 2x minus this, that is 2x. Okay, so minus this is 0, this minus that is 0. So we're left with this. Okay, so at the end of the day, we now have that this, which is the quotient, plus this over this, plus the dividend, okay, over the divisor. I need you to notice that this can easily be integrated, and this, the later fraction, now have the power, the numerator now have a degree of 1, and the denominator now have degree of 2. This is what we want to achieve. We want a situation whereby the power of the highest power of x at the numerator is less than the power of x at the denominator. And then we look at it critically and see that, oh, if we try to differentiate this using substitution method, it will not work, because if we differentiate this, we will have 2x minus 1, and then we don't have 2x minus 1 on top. Had it been this is minus 1, would have used substitution method, and then we work out of the integration successfully. But because of that, the only way to solve this problem, to integrate this problem, is by resolving it into partial fraction, and then we integrate afterwards. Okay, so I believe you are following what I'm saying. If you don't grab anything I say at any point, please make comments, and then we will talk about it. All right, so with that being said, let's integrate. So before I integrate, let's resolve this into partial fraction. So we'll have 2x minus 7 over x squared minus x minus 2. All right, so we factorize this. We have uh, uh, two numbers. If you multiply them, you have minus 2, and if you add them, you have minus 1. What are those two numbers? Okay, those two numbers are supposed to be minus 2 and 1. Okay, so we'll have 2x minus 7 all over x minus 2 and x plus 1. All right, so that if we do x times this, we'll have x squared. Let's be sure of what we're doing. This time that we'll have plus x. Okay, and then this multiply this, will have minus 2x. Okay, and then this time this will have what? This time we'll have minus 2. So this in the middle will be x minus 2x, which is minus x. So we are right. If you're not sure of what I just did, you can ask questions. All right, so this is the two factors. Now let's resolve this into partial fraction. So we now have that we have two distinct roots. So if you look at the first example, we're applying what we did in our first example here. So we have a over x minus 2, and then b over x plus 1. All right. So now the LCM is still what we have here, x minus 2, and then x minus x plus 1. Okay. So what we're going to do is this divide this is this times that. So we're going to have ax a bracket x plus 1. We close the bracket. Then if you do this divide that, you have this times that. So you're going to have b bracket x plus, sorry, minus 2. Okay, good. So now we're going to find the value of a and b. But before we do that, uh, we are going to we're going to collect like terms. So we have that this is equal to ax, okay, plus a, then plus bx minus 2b, okay, all over x squared, x minus 2, and x plus 1. So remember this is equal to 2x. Please don't mix this up. I just want this to be here. Okay. Better still, let me clean it up. We don't need to forget this. The 2x. We don't have to forget it. Okay, so now we have 2x minus 7. Sorry, let me change the color back. 2x minus 7 over x minus 2, and then x plus 1. So this this goes with this, okay? And then we group this. We now say this implies that a plus b, okay, bracket x, then a plus a minus b plus a minus 2b, sorry, okay, 2b is equal to this, is equal to, let me write it here because of space, equal to this. So by comparison, don't get confused. All right, so by comparison, mm, comparison, we have that a plus b is equal to, if we compare both sides, the coefficient of x on the other side of the equation is 2. So a plus b is equal to 2. We call this equation 1. And then a minus 2b is equal to minus 7. We call this equation 2. All right. All right. So now we can eliminate a to find b. It's easy to eliminate a to find b. So using the elimination method, a, equation 1 minus equation 2, a minus a, 0. B minus minus 2b, 3b. Okay? Equal to 2 minus minus 7. That is 9. So this implies that a is equal to 9 over 3, which is 3. Oh, sorry, this my 3 is somehow. Okay, so now we have that. Now we're gonna substitute a in equation one. So a, sorry, error. This should be b. Hmm, b. So substitute for b here. So that means a will be equal to 2 minus 3, which is minus 1. So a is equal to minus 1. So now we are falling back on this. We are gonna fall back on this. I hope you are following. If there is any confusion somewhere, please let me know at the comment section, and then I'll be glad to assist you. Okay. So remember, we had resolved this initially using long division method, and we got 2x, the quotient, plus this, which is 2x minus 7 over x squared minus x minus 2. Okay. And this is equal to, right now, this is equal to 2x again. Okay. Plus a. What's our a? Our a is minus 1. So I'm going to do it like this, minus 1. Or better still, minus 1. Let me put b first. So this b is 3. And under 3, we have plus 1. Okay. And then we'll this minus 1 over. So we don't mismanage our signs. Okay. Over x minus 2. So we can now integrate both sides. So we introduce our integral. The integral of this is the same. Integrate both sides. dx dx. So if we integrate 2x with respect to x, we're going to have x to the power 2, 2 over 2. Okay. Then if we integrate this, we're going to have plus 3 ln of x plus 1. And then this will be minus ln of x minus 2. So this cancels that. We have x squared plus 3 ln x plus 1 minus ln of x minus 2 plus c, constant of integration. All right, so we are done solving this particular problem. This is our answer. All right, thank you for joining us today. If you have any problem, problem on this, in this line, Any problem that looks like this that you're having challenge with, bring it on. We talk about it. We solve it together. See you in my next video. Do well to subscribe if you're a newcomer. If you are old, thank you for subscribing. See you in my next video. Bye bye.